Hello, is that David?
No, he's not
Oh,
around.
okay. Okay, so who's helping us today?
Hot.
Oh, Kotso.
Yes,
Okay,
Prof.
okay. Thanks for being here, Kotso.
Thank you, Prof.
You'll know how to mute people who are disturbing us.
Yes, I will do that, Prof.
Yeah, well, I'll give them 3 warnings. I think maybe 2 or 3 warnings, and if they
Okay,
still persist, then we'll have to take them out. I don't like doing that, but you
no
know what
problem.
has happened in the last 2 sessions. Yeah,
Yeah, I saw.
yeah.
Okay.
You already started recording. I think you just stopped
Yes, it's
recording until
already recording. Yes.
yeah. It's just record when I tell you to when I'm going to start.
Okay, should I pause it now?
Yeah, just stop it now, and then when we start, I'll tell
Okay,
you
no
you can
problem.
start recording. Okay,
No problem.
because we are.
Is it recording, Prof?
Yeah, okay. Yeah, I think so. Good evening, everybody, and welcome once again to the second session of the senior training program organized by the South African Maths Foundation, to whom we are very grateful. And I also want to welcome Khotso, who represents the Maths Foundation at this meeting, and he will be helping along with the logistics. I'm going to say this now, and I'll say it maybe 1 or 2 times more. Please make sure that your microphone, your audio is off, because we don't want any outside disturbances. If there's a dog barking in Lobo's room, the entire group of 25 people will be able to hear it. So please take those mics off. If you get any interference, we know exactly where the interference is coming from. I'll give you one more warning, and after that, we will take you off the class. We'll put you into the waiting room, and you would not be allowed to attend the class. And I'm sorry to start off with a sour note like that, but sometimes when people don't follow instructions, then it makes the presentation very much more difficult to handle. Okay, so let's go, because today we have a rather interesting program with a lot of fine problems, and we have many problems. So it's going to be, I'll have to go a little bit briskly. These program, these sessions are being recorded, and you can, all of you have access to the recording. You can consult with your center manager to find out how you can access those recordings. In case you don't understand certain aspects, you can go back to the recording, stop it, rewind it, and so on, so that you get a full understanding of all that I am saying. Okay, so even if I go briskly, you have an opportunity to go back to it. Okay, I'm going to share with you um, okay. All right, so last week we did not finish all the problems. There were quite a few problems and we didn't finish it, and I promised that I will come back to it. So what we are going to start off with, the unfinished problems. I don't think I'm going to do all of them, but I'm going to do some of the unfinished problems starting from last week. So we'll have to move quite briskly. Okay, so if we go to the first problem. All right, so here the problem says between 12, between maybe noon and 1 o'clock in the afternoon, there are two times when the hands of a clock are exactly at right angles. How many minutes apart are these two times? So I've drawn a picture here. So at 12, the hour hand and the minute hand were in line. I presume that all of you know about the old-fashioned clocks. They are still in vogue, but most of these present clocks are digital. But these clocks we are speaking about has got 1 to 12 in it. Okay, so if the minute hand and the hour hand are both at 12, that's 12 o'clock, then what happens is the minute hand starts moving much faster than the hour hand. And as the minute hand moves, it separates from the hour hand. This is the hour hand that I am pointing to. Okay, let me just highlight that. Okay, it doesn't matter, I can't highlight it. So after a short time, the angle between the hour hand and the minute hand is 90 degrees, as you can see here. So this angle here is 90 degrees. But then, as it goes up to 12 again to get to 1 o'clock, then this line moves from 12 to 1, and this line is speeding up towards 12, and there will be another angle where the minute hand and the hour hand are exactly at right angles apart. So the question is, how many minutes apart are these two times? So there's one time where the minute hand is at 90 degrees, and the next time it's again at 90 degrees. So the question is, how many minutes apart are these two times? Right, now this problem, if you have not familiar with this, it can be quite difficult. So I've drawn a picture here. I am saying that the hour hand has moved X minutes when at 90 degrees. So now remember, at 90 degrees, it means that these black lines are 90 degrees. It's a 90-degree angle, but in terms of minutes, 90 degrees in a circle is actually, you got 60 minutes on a clock, all right? So 90 degrees is actually 1/4 of 60, which is 15, quarter past, half past, quarter to, and so on. So there is a 15 minutes here. So from that point to where the hour hand is, it's 15. So this hour hand has moved X minutes. So therefore, the minute hand would be at 15 plus X. Okay, it has moved, in itself, it has moved 15, but the hour hand has also moved to X minutes. So the angle between them is 15. The time here, the hour hand will be, the minute hand would be at 15 plus X. And likewise, I said that the hour hand at the second 90 degrees is at Y minutes. It's moving towards 1, remember? And then this angle here is 90 degrees. Okay, so this is 15 minutes here. But now we are talking about where is that one, right? It's closer to 60. So what happens is that the hour hand would have moved through you see this entire angle here is 45 minutes, right? So if the hour hand was at Y here, then the minute hand would have been at 45 plus Y. Okay, so this is the picture here. I hope you understand exactly what's going on here. Right, now we need to get to equations. It's only when you got equations can you solve problems. So what is the relationship between the minute hand and the hour hand? Now that's a very important question. The hour hand, the minute hand moves much faster than the hour hand. How much faster? Well, we do know that when for the minute hand to move from 12 to 1, the hour hand would have moved from 12 to 12 again. So when the minute hand has moved 60 minutes, the hour hand has moved only 5 minutes. So the lesson from this is that the hour hand is moving 12 times faster. We'll call it HH, right? As speed (12 times minute hand, mh). Okay, so what does this mean? It means that this minute hand 15 plus x, when this is here, it's moved 15 plus x. This is 12 times whatever the hour hand has moved, and the hour hand has moved x. So this means that 15 plus x, when the minute hand has moved to this point, it's traveled 15 plus x minutes, then the hour hand would have traveled only x minutes, and the one is 12 times faster than the other. And this makes, if you bring all the x's to one side, we get 11x on this side and 15, so you can say 11x is equal to 15. X is in minutes, remember. And likewise, the other scenario is when the hour hand has traveled to 45 plus x, then the minute hand has moved only to y. That's a red one. Okay, so that speed is also 12 times, and this time you have 11y. Oh, I'm sorry, 45 plus y. That's 45 plus y. 11y is equal to 45. Right. Now the question is, how many minutes apart are these two times? So what is the question? The question is, how many minutes apart? So in other words, this is y minutes, this is x minutes. The question is, what is y minus x? That is the question. How many minutes apart are they? We're not talking about angles, we're just talking about the minutes. All right. Now from here, you'll be able to get y minus x. Oh, I should say, now how many minutes apart are not these two times? The two times are, one is 45 plus y minutes past 12, and the other is 15 plus x minutes past 12. So this is the one time is 45 plus x, or 45 plus y, sorry, and the other time is 15 plus x. Okay. Milasaka, can you please put your mic off? This is the last time I'm going to tell you that. So we've got, so this is the question. How many minutes apart are they? This is 45 plus y minutes, 15 plus x. So we need to work out this. So now what is this? If you simplify this is 15, 45 minus 15 is 30 plus y minus x. I'm simplifying that. So we need to know what is y minus x to get the answer. And here you can see I can get y minus x by simply subtracting these two. Second equation minus the first equation. And that 11 comes out as a factor. And you get y minus x. 45 minus 15 is 30 over 11. 11 times y minus x is 30. So y minus x is 30 over 11. So the answer that you're looking for The number of minutes apart is 30 plus 30 over 11, because that is what we said earlier. And 30 over 11 is 2 and 8 elevenths, so that's 32 and 8 11 minutes. All these are calculated in minutes. Okay, if this is the first time you've seen this kind of a problem, it can be quite mind-boggling. So study it very carefully and listen to all the things that I've said, so that when you listen to the audio recording, they'll have a good understanding of the way this thing works. All right? So we just work with minutes. I used to work with angles at one time, but it was very, very complicated. But with minutes, it's very much easier to understand. Okay, so let's get on to the second problem, which I missed last week. And that is this problem. Oh, the question there was, yeah, a rectangular based pyramid is shown. So in this diagram here, you've got all right, the arrow works. So here you've got a pyramid and it's rectangular base. In other words, ABCD is a rectangle. And the vertex P in a pyramid has got a vertex. This P is vertically above D. So this corner of the rectangle, this is vertically above. So when you draw the vertical, the perpendicular down, it'll hit. I like to think of this as the floor. ABCD is the floor, and P is, in fact, you can think of this whole thing as a corner of a room. See, there's a floor, and P is vertically above D. So this is the corner of a room here. And so this means that this angle this is 90 degrees here. And this is a rectangle, so all these angles are 90 degrees. Although it looks like a parallelogram, but since we are drawing it in 3 dimensions, you'll have to think of a corner of a room, and that corner there is, even this is 90 degrees here. So you got 390 degrees here, and that adds up to only 270, not 360, because you are working in different planes here, you see. One is vertical and the other is horizontal. Okay, it's also given that BC is equal to 8. So that is 8, and AB is 12, and PC is 15. Right. Now it says an ant crawls from the center of the base. Now the base is here somewhere. This is the base, the floor. Right? And the ant crawls from the center of the base to the point P, to a point P along the shortest route. Okay, so just think of this ant as being on a floor. Think of this thing here as a floor. Think of this as a wall, and this is another wall, the 3 walls at the corner of a room. If you think of it like that, then you'll have a better idea as to what it is. And this point here is at where these 2 walls meet, right? And it's at a certain height above this floor. And this ant now, it crawls. Now, our first guess will be the ant, it's crawling, it'll go to D, and it'll go up, because it says the shortest route. So it looks as if it'll go up to D and go up, and that would be the shortest route, right? But actually, that is wrong. Your intuition will not direct you to the correct answer. It looks as if you're going to go to this point and go up that to give it the very shortest route. The actual what happens if you work this distance out here, I did work it out somewhere. I think I had something like whatever. Okay, but if you take this root, you'll get something. I think you'll get square root of 117 or something. All right, but this is the way to do this is, you see, the ant, it will take the shortest, it will take a straight line joining this point to that point. The straight line is the shortest distance, right? But the straight line is, it can't be in the air now. The ant, now this will be in the air. You see, if you join this point to that point, this line here will be in space. And obviously the ant can't walk in space. But what it will do is walk straight line from here to there like this. Now, here it is. I've got the floor as A, B, C, D here. The ant is in the middle of this. And what I'm doing now is I'm taking that triangle there, PDC, and I'm flattening it out. PDC is now flat. It's not vertical. This whole wall, if you like, has been flattened to be just an extension of the floor, like what we've got here. So I've drawn that. And if you think carefully, the shortest distance will be the ant will have to travel from O to P, but it'll go along the floor and it'll climb up that wall, which I've now flattened, right, and get to P. So the shortest distance is actually OP. Okay? Not OD plus DP. OD plus PD. That might, your intuition would have told you that. So now we can work out OP. Now OP, to work this thing out, I have to complete the right angle triangle, right? Because OP then, remember this whole thing is in the floor now. All this in the floor. So you got the 90 degrees here and you got 90 degrees here, right? That's a straight angle. And OP is, when you drop a perpendicular here, OP is the hypotenuse of a right angle triangle. And you can use Pythagoras to calculate the hypotenuse. This side here, since it's right in the middle, this whole thing is 12. So this thing here is 6, right? And the other side of this triangle is this one here, from P to this. We can call it P to E or something, right? And that is the sum of this O. Now, we don't know what PD is, right? I put down 9 here, but this is because I calculated it. You see, there's another right angle triangle here. And the same right angle triangle which was on the wall. So now this is 15, and this part here is 12. These are two sides of a rectangle. This is 12. So you can work out what PD is using Pythagoras. So PD is the square root of 15 squared minus 12 squared. 15 squared minus 12 squared. And if you work that out, you get 9. So this is 9 here. Now, from here to here, again, this is the middle of this. The whole thing is 8, as you can see. It's the opposite side of a rectangle. So this, we're talking about the side here. That's 8. And the midpoint of that is E. So this part here is 4. So you have 9 contributed by that wall and 4 because it's the midpoint, and that gives you 13. So OP is actually the square root of 9 plus 4 is 13. 13 squared, and the other side is 6 squared. So that is square root of 169 plus 36, which is square root of 205, which is the answer. We are not told whether these are meters or what they are, just no units are given. So we just leave it as 205. So that is how you solve that problem. as you can see, it's a fairly challenging problem, but it's the kind of problem that they do ask in Olympiads. All right. So the next problem now is, if you have any queries, I've said this before, you can put it into the chat column, all right? And if I ask a question, a rhetoric question, and you got the answer, you can put it in the chat column. And as I told you previously, there will be no discussion, unfortunately, in this session, during the session. But at the end of the session, I'll leave this thing open. And if you got any questions, you can ask that. Some people want to go away, that's fine. But whoever remains behind can ask the question, and then we will try to address it. So just keep a record of your question in the chat column. Okay, now we want to get to this problem here, which is saying that, oh, it's another story of an ant. Oh, you seem to be very interested in ants today. Let's see. Supposed to be an ant. An ant lives on the surface of a cube, small world, that has points X, Y, and Z. So on the surface, you got 3 points, as you can see, on 3 of the faces. The ant travels between X, Y, and Z. So it travels from between each pair of points. In other words, the ant travels from X to Y, Y to Z, and Z to X. Right? So it travels along the shortest paths. Right? Now this is quite similar to what we saw before. For the shortest path from X to Y, you have to lift the space up. And so what happens here from X to Y, if you were traveling, so if I use, this is the top face, X is somewhere here, whatever, and Y is here, and then it travels along the shortest path. So it'll have to be this. Okay. Now, I want you to notice, okay, I'm analyzing what you mean by the shortest path. Right? And you can do the same thing from Y to Z and from Z to X. All right, now the question is, what is the sum of the 3 indicated angles X, Y, and Z in the ant's path in degrees? So you got an angle here, X, you got an angle Y here, and you got an angle Z here. And the question is, what is the sum of those 3 angles? So in other words, the question says, what is X plus Y plus Z? You must always bear in mind what your goal is, right? The sum of the 3 indicated angles. Now, these 3 angles are pretty badly dislocated in this triangle, and this is not a triangle, X, Y, Z. You know, it's far from a triangle. In fact, X is an angle in a quadrilateral. This part here is a quadrilateral. X is an angle there. And likewise, Z is an angle in another quadrilateral, and Y is an angle in the third quadrilateral. So X is just one of these angles in some quadrilateral. Okay. Now, what I'm going to do is, to get X plus Y plus Z, I'm going to add all the angles in the 3 quadrilaterals, the whole lot. So, because then I'll get my X plus Y plus Z. Now, that takes care of only 3 angles. But these 3 quadrilaterals have got 12 angles altogether. Right? Now, let's just follow what the angles are. I want to add these two angles together. And those two angles are these two angles here, you see. Because this angle is that one, and this angle here is where you are joining this. So the sum of these two angles is 180. Those two angles add up to 180. And in a similar way, those two add up to 180, and those two add up to 180. So you have 3 times 180. So these are 6 angles here. I've got 2 here, 2 here, 2 here. So I've got 6 plus 3 is 9. There's still 3 more angles to account for, right? As far as this triangle is concerned, this quadrilateral at the top is concerned, I've already taken care of this angle here and that angle, right? And I've taken care of that because there's X there. The only angle I haven't taken care of is the top, that 90 degrees. So likewise, the 90 degrees here and the 90 degrees here, those are the 3 missing angles. All the other angles are in the sum, right? So you got 3 times 90 degrees. So this takes care of all 12 angles in those 3 quadrilaterals, right? But you know that the angles in a quadrilateral add up to 360 degrees. In any quadrilateral, the sum of the angles of a quadrilateral is 360 degrees. Sum of angles of a triangle is always 180, but in a quadrilateral, 360. And there are other formulae, which I'm not going to go into, for higher order polygons. Okay, so all this is equal to the 3 quadrilaterals, each is 360. So altogether, these 12 angles add up to 3 times 360. So you got everything here except x plus y plus z. And when you calculate it, you see it's 270 degrees. I'm not going to do that. That's now, you just have to take these numbers to the other side and make the calculation. Okay, so that was quite a challenging problem. But again, now you're looking at angles in 3 dimensions, you see. When you're moving out of the flat surface and moving into cubes and all that, like even the wall story earlier on, then you have to figure out exactly what angles you're talking about. Okay, and then I go on to the next problem. This problem says, what is the exact numerical value of this? You're not allowed to use a calculator. So anybody who looks at this will say, what? You're multiplying 5 by square root of 2. I'm not allowed to use a calculator, plus 7. And then I'm working out the cube root of that. This is 1/3 is the cube root of this monster. And the same thing here, you got a cube root of another monster. And you are supposed to see what the difference is. So it looks as if this is really a crazy problem, something that is impossible to do. But you will be pleasantly surprised to learn that we can calculate the exact value of this. And all it requires is algebra. So the idea for me, this is all about the power of algebra. You see? Last week I also, when I had a number, I gave it a name. So I'm going to give a name to this rather clumsy object, 5 root 2 plus 7. And I'm going to give a name to the other clumsy object, 5 root 2 minus 7. All right? So the idea is, what are we trying to calculate? We're trying to calculate why don't I make, I'll make A to be equal to the cube root of the whole thing, and B to be equal to the cube root of the whole thing. So I'm calling A, I'm giving this first monster, I'm giving it the name A, so this is A. and the whole thing there is b. So the question is, what is a minus b? Right? So that makes this thing a little bit more manageable because now you got symbols. Okay, now if a is a cube root of that, let's do the calculations. If a is a cube root of that, what does that mean? It means that when you cube a, you're going to get to 5 root 2, 5 root plus 7. When you cube b, likewise, b is a cube root of this minus this, so you're going to get 5 root 2 minus 7. Okay, now you got a cubed and you got b cubed, and you got a minus b. And then, if you think a little bit, there is a connection between a cubed and b cubed and a minus b. Because all we have to do is to subtract these two, a cubed minus b cubed. Right. Now, the factorization kicks in here. A difference of two cubes, a minus b, that's exactly what we want. Let's call this thing x. We'll call a minus b x. That's your unknown. So I'm not going to substitute right now. A minus b, and the other factor is, if you know your factorization, is a squared plus ab plus b squared. All right, so we don't know what a minus b is. That's what we're trying to find out. We don't know what a squared is. We don't, oh, a squared, we can, but it's become even a bigger monster. You're squaring a cube. So yeah, I don't want to deal with a squared. But ab is something that I can handle because I know a cubed and b cubed. So I can work out ab because if I multiply these two, a cubed times b cubed, you get this, that plus 7 times that minus 7. And that is a very nice, well-known friend. A plus b, x plus y into x minus y is x squared minus y squared. So when you multiply these two, you're multiplying these, and that is x plus y into x minus y. So it's x is 5 root 2. So when you're squaring this, you get 25 times 2, which is 50. 50 minus 49. It's 1. Okay, that's a nice, very pleasant number. So a cubed, b cubed is actually equal to 1. So when you're cubing ab, you get 1. So that means ab is 1. Okay, which is very nice. So we know what ab is. So that's 1. Okay, now this is your unknown. We're going to call it x. Now what about what is left behind here? A squared plus b squared. Now how do you work this out? You don't know a, you don't know b. Well, you do know what a is, but it's horrible. But if you think carefully about this, you can relate this to x. Because a minus b, if you square it, I just want to write this down here. X squared, x is a minus b. It's x squared, a minus b all squared is a squared minus 2ab plus b squared. And lo and behold, you got a squared plus b squared here. All right? A squared plus b squared. So a squared plus b squared is x squared plus 2ab. Because if you take it to the other side, you'll get 2ab. But we already know that 2ab is 1. So this is x squared plus 2. So a squared plus b squared is actually x squared plus 2, which is very nice. So when you add these two, you get x squared plus 2. So now you've got that, now what about a cubed minus b cubed? You got a cubed, and you got b cubed, and if you subtract these two, right, these cancel, and 7 plus 7 is 14. So the left-hand side is 14. It's a cubed minus b cubed. When you subtract these two, and here you got x, and here you got x squared plus 2 plus 1. So this is x squared plus 2. We saw that down here. You're adding 1 to that, so it is x squared plus 3. So now you got an equation for x. In some magical way, you got an equation so you can solve for x. But unfortunately, it's a cubic equation. You got x cubed, and we don't know how to solve a cubic equation. So this is where trial and error can be very useful. So let's try. We know the answer is supposed to be some nice answer. So let's try different values for x. When x is equal to 1, you will see it's 1 times 4. That's wrong. When x is equal to 2, you'll see it's 2 times 2 squared is 4, 4 plus 3. 4 plus 3 is 7, 2 times 7 is 14. Lo and behold, wow, so x equals 2 works. Right? It's a solution to that equation. And that's exactly what a minus b is, which is incredible. I find this quite fascinating, that you got two horrible numbers, and if you subtract it, you get exactly 2. You try this thing on a calculator. I think you should try it on a calculator. Work this thing out, work the cube root of that, work this cube root, and you see your answer is 2. But the calculator is saying so, right? But we can say using pure algebra, you can see I'm using some nice algebra here. A cubed minus b cubed and so on. Factorization. Okay, so that takes care of the last problem of last week. So, which means that now, after almost 45 minutes, we now can get into today's session 2 problems. But those were the hard problems, as you saw. But now, they were right towards the end of that session. So now we can go to the other problems, which you might think is easy, but it need not be. Okay, let's go to the first of the session 2 problems. By the way, I have changed some problems. I found that some of these problems were not quite suitable, and I had them, some of them, some of the difficult problems happened to go into the junior group. So I pushed them into the senior group and took out the easy problems from here and pushed them into the junior group. So there's a little change in the program. If you look at your book, your problem book, you will see that some of these problems are not the same. All right. Now, while I'm on that, I just want to show you something. You see, the problem book, I trust that all of you have got the problem book. And what we are doing here is we are doing the sessions. You got in the same problem book, you got the senior problems as well as the junior problems. The senior problems are in the latter half of the book, right? But I put the junior problems there mainly for the juniors because they might want to have a look at some of those bright junior kids might want to look at the senior problems. But in any case, there are lots of junior problems and there's common problems to both junior and senior. Right? I don't distinguish between what grade you are. It's because many of these don't require too heavy mathematics. It just requires a lot of thought. All right. So the problem book, towards the end, that's where the assignments are. And you already were given the first assignment. And the second assignment will be the assignment for session 2 of the seniors. So you go and check that out. And there you will see what that assignment is. But right towards the end of the book, I've got some useful things. And that is what I quickly wanted to talk about. And that is towards the end of the book. I don't know whether I've saved it. Maybe I didn't. Okay, I don't want to waste time. I thought I saved it, but evidently I didn't. Let me try one more time. Yes, I did. Right. I got right towards the end on page 54, something like that. You got hints to solve problems in this book. So you will see the actual reference. Oh, I don't know how this reference works, but anyway, you got lots of formulae here, right? And sometimes if there is a problem, oh, this is session 1, I think. I think this is session 1 up to 10. Okay, whatever. You can figure it out. I can't seem to be making much progress with this. Um, so you got various kinds of formulae here, and they will help you to solve certain problems. And I've referenced them in a certain way. I can't remember exactly what these references are, but you can figure it out. And they cover the entire uh, sessions for all 10 sessions. So that if you get stuck, you can always go to the back there and see what formulae are involved, and then you can go and try to tackle those problems, because those formulae sometimes you might not have seen before. Okay, so that's just to help you along. Okay, now let's just get to this problem here. How many odd positive integers, the sum of whose digits is 4 and none of whose digits is 0, are not prime? Right, so you know two things about this. Namely, the sum of the digits is 4. So that's a small sum, right? Like for instance, 13 is an example. Of a number having the property that the sum of the digits is 4. All right, let's try to find out what all these numbers are. Right, 13 is one such example. So let's try to, in some systematic way, to decide how we can list the whole lot of them out. So they don't tell you how many digits it's got. So I'm going to put, say, suppose you work it according to the digits. How many one-digit numbers have you got? Two-digit numbers have you got? Three-digit numbers have you got? And four-digit numbers. The one digit is easy because that's the only one-digit number with sum is 4. And 4 digits is also easy because if you've got 4 digits and the sum is 4, there's only one number which will satisfy that. Okay, so now let's try to list all the two-digit ones. I saw 13, so they're adding to 4, but you can also add, to get to sum 4, it's either 1 plus 3, and that gives you two numbers, or 2 plus 2, and that gives you one number. That is 22. That's the only two-digit number which has got 2's in it. Now, the three-digit numbers, how do you get three numbers to add up to 4? The only way you can get three numbers to add up to 4 is, so if it's 1 plus 1 plus 2, right? So you'll have 1, 2, and 2 1s. So I can write down 1, 1, 2, as we saw here. But the 2 here is occupying the third place. I can make the 2 occupy the second place, you'll get another number. Or I can make 2 occupy the first place, right? Okay, and that takes care of all the possible numbers that add up to 4. There are quite a lot of them, eight of those numbers. Now, let's now look at what the restrictions are. They are odd. So we must take that out, take that out, and take that out, right? So the only survivors are these numbers. Right? I didn't include 0 because it said you're not allowed to include 0. But they're also not prime. All right, so in other words, you have to take out all the composite numbers here also. Right, now 13 is prime, so that goes in. But this thing here, 121, is 11 times 11. And the kids will say, what 8 times 8? They'll say 88. 9 times 9 is 99. 11 times 11 is 11 to 11. So this is 11 times 11. So we have to take that out because you want them to be, they mustn't be prime. Okay, so this is included now. That is included. Now even this too is included because no, actually 30, it's prime, so you can't include it. You have to take it out. You have to take it out. 11, this is 11 times 101. 11 goes exactly into this. So this is not prime, so you must include that. The only thing is this one here, is this prime? Well, you have to check it out. It'll take a while to try all the prime numbers from starting from 2, 3. You only need to see if all the prime numbers before this go into this. So you have to try 2, 3, 5, 7, 11, and so on until you exhaust all the necessary primes. And you'll see that this is also a prime. So I must take it out. This is a prime. Okay, so there are only two numbers which satisfy this. So how many? You must answer the question. There are two numbers. They're not asking you for what the numbers are, but the numbers are 121 and 1111. Okay, I'll just pause here for a moment and see if what you guys are saying. There's only one chat that was right in the beginning. So now let me just open the floor out and see, are there any urgent questions that you want to ask? Is there anyone who has got a query or a question or comment? All right, if there's no questions or comments, which is good, it means that you are following what I am saying so far. But even if you don't, as I said, you can put it on the chat column and we'll address it later. And even if you fail in that, you still got your center manager and you've got tutors who have been appointed to help you, right? So these tutors are also paid. So you can take advantage of that and find out who your tutors are, and you can go and talk to your tutors and get answers to questions which you are not, which you don't know. Okay, so let's get back to our why can't I leave this thing? Just one moment, I'm having some problem with this. Right, okay. And let's get on to the next problem. Okay, the next problem says, how many factors does this thing have? All right, now if you go to the hints, which I would like you to do at some point, I just told you, I think the hints was on page 54 or something. All right, you will see there is a formula for the number of factors. The formula says that if a number, let's call it n, has been factorized fully. Now, what do I mean by that? If I take a number like 36, That is 4 times 9. And that is 2 times 2 times 9. 2 times 2 times 3 times 3. And you write it as 2 squared times 3 squared. So when I say factorize fully, you write it as products of powers of primes. So equal primes, you put them together as powers. So you have any number can be factorized as product of powers of primes. For instance, if you take 1008, that is 2 cubed times 3 squared times 7. See? So you can write any number as a product of powers of prime numbers. All right, so if you write this a number as a product of prime numbers, let's call these prime numbers P1. In fact, you can call it starting from 2. And we'll call this the power N1. And the next prime is 3 and 2, 5 and 3. So I'm writing down all the possible primes here, because this could be 0, you see. 2 to the 0 is 1. So if the prime is in that, like here, it's 2 cubed times 3 squared times 5 to the 0 times 7 to the 1. So I can write down all the prime numbers, but some of them will be 0. Right, now, the number of factors there's a formula, equals, you take each of the powers, N1, add 1, bracket it. Then take the next power, N2, add 1, bracket it. Now you multiply these things, N3 plus 1. So you multiply all these numbers. You take the powers or the exponents or indices, whatever you want to call them, increase each of them by 1 and multiply them. That gives you the number of factors, which is very nice. Like, for instance, if you take 36, the number of factors for 36 is 3 times 3, which is 9. You increase these two, 3 times 3 is 9. Here, the number of factors here is 4. Let's look at this. This is how it's written here. So it's dot, dot, dot means you have other primes involved. So the number of factors for 1008 is 4 times 2. And now 0 times plus 1 is this 1, and 7 times 1 plus 1 is 2. Now you see, when you multiply all these numbers, and one of the numbers is 1, it's just 4 times 2 times 2. Right? So we can leave this out because it's not contributing anything to the product. See? So that is why, if it's like that, that's fine. Because now that's 4 times 3, 2 times. 4 times 3. You're increasing 2 by 1. So this is 4 times 3 times 2, and that is 24. So this number here has got 24 factors. So in this, so our answer to our problem, increase each of these exponents by 1. You don't have to put the 2's and all that, as we saw, right? The 0 powers we can ignore. So only those where the powers are not 0 feature in this thing. So it's, you increase all the exponents by 1, and you'll have 2 times 2 times 2 times 2. Because all the exponents are 1. So if you increase each of them by 1, they then becomes 2. So 2 times 2 times 2 times 2, and that is 16. So this thing has got 16 factors. In fact, you can try to list all the 16 factors to convince yourself that that is the correct answer. I know some of you would have tried to write down all the factors, right? And you may or may not come to 16, but it's somewhat unlikely you'll come to 16 unless you have a system in which you are doing the counting, because you can miss out a couple of factors. But this thing here, you don't have to list the factors at all. That's the beautiful thing about this. You don't have to write down what the factors are. You can immediately write down how many factors there are. Okay, so this next problem is just going in the same lines, Find all numbers less than 50 that got exactly 4 factors. All right. So now we don't know what the numbers are, but we know how many factors it's got, and we have a formula. This is number of factors is equal to 4. You see, it's got 4 factors. But now this is okay. So let n be such a number which has got 4 factors. So if we write down n equal to 2 to the power of n1, 3 to the power of n2, 5 to the power of n3, and so on, right? Then now we are going to assume that all these are greater than 0. No, they are greater or equal to 0. So when you multiply these numbers, you're going to get 4. All right. So you've got a number of numbers whose product is 4. Now, what are the possibilities? The only possibility is a 1 times 1 times 4. But the 1 here means n1 plus 1 is 1, so that n1 is 0. So I must ignore that 1. So I'm going to just put 4 or 2 times 2. We shouldn't put down the 1s in the factorization because those will contribute to 3 to the power of 0, which is 1. You can hardly regard that as a factor. So there are only 2 possible ways you can get to 4. So this means that here you've got only 1 prime number. So you've got n is equal to a prime number. We call it p. We don't know what it is. Could be any one of these, but it's p cubed, because this kind of a thing will give you the number of factors is exactly 3 plus 1, which is 4. Right? There's only a single prime number, which is a factor of that number. Or, in this case here, it's a product of 2 prime numbers. Let's call it PQ. Both of them are prime, because we're taking prime factorization, you see. But this first 2 is coming from a 1 here. 1 plus 1 is 2. And the second one is also coming from this. So this is just PQ. So in short, what we have here is that these numbers have two types. Either it's a cube, so either n is a cube, of a prime number, or a product of 2 numbers, or a product, yeah, or a product of 2 primes. Only in these cases will you get that the number of factors is 4. You see, in this case it's 2 times 2, and that case there it's 3. Just 4 by itself. 3 plus 1 is 4. Right. So now you need to know all the numbers less than 50, which are either cubes. So which are the cubes under 50? You can say 1 cubed, 2 cubed, it's 8. 3 cubed. Oh, no, 1 is not a prime. So we're going to take that out. 2 cubed, 3 cubed. Now this is 27. And 5 cubed is more than 50. It's 125. So you can eliminate that. So here you have only 2 numbers, 8 or 27. Those two numbers less than 50 have got exactly 4 factors. The other ones, product of 2 primes, now that will take a little bit of time, because now you're going to say, if the first prime is 2, right, then it'll be 2 times 3, 2 times 5, 2 times 7. And the last one you'll go to, you want it to be less than 50, we can go to 2 times 23, which is 46. And the next one will be 2 times 29. That's 58. It's too high. So all these, I've got 2 as a factor. Then you can write down 3 times what, or 5 times what, and count all of them, right? So these numbers here will have 3 as a factor, but they wouldn't have 2 as a prime factor because we've eliminated all that. And then here, 3 is a prime factor, and you'll have 3 times a larger prime number. And here you have 5 times a larger prime number. In this case here, you only have 5 times 7, because the next one will be 5 times 11, which is too much, right? So you can count it. I think you have 15 altogether, if I'm not mistaken. I'm not sure, but I think it's that. Anyway, let's get on to the next problem. And the next problem is it says that P and Q, oh no, okay, we're doing this one. Okay, if P and Q are natural numbers, and the natural numbers are the counting numbers, 1, 2, 3, 4, and so on. P over Q, so the fraction is, when you write it as a decimal, it's 10 3/4, 10.6. Okay. All right, so P over Q is I'm going to write this 43 over 4. Now, I want you to notice something here. You know, when you're writing this as a mixed fraction, 43 over 4, you'll see how many 4s are there in this, and you see it's 10. So 10 is a quotient, and the remainder sits on the top there. This 3 is a remainder. When 43 is divided by 4. I'm making a point of this because this is very important in this problem here. That when you write it as a mixed fraction, then the top part is the remainder. When you divide 43 by 4, the numerator by 4, you write down, take out the integer, this is the remainder. It has to be less than 4. Okay. Now, here's something. This is not you can't say that P equals 43 and Q equals 4 here. That will be wrong. Because you can multiply the top by 2, and you can multiply the denominator by 2, and this is still the same fraction. When you simplify this, you'll get exactly that, and that'll be 10.75. So P is not 43, it could be 86. Right. But what we can say is that P is 43 times an integer. M could be 1 or 2 or 3 or something. But at the same time, if you are multiplying this by M, you have to multiply the bottom by also the same thing. See, now P over Q is 43M over 4M, and the M's cancel, and you get this. So there are lots of possibilities for P and lots of possibilities for Q. So just by looking at this now, you can't say what P is. That is the lesson of the story, moral of this of the story. So, but you can say that P is a multiple of 43 and Q is a multiple of 4. It's the same multiple, so that when you cancel, you'll get 10,75. Now they say when P is divided by Q, the remainder is, when it's divided by 2Q, right? The remainder is 9. So let's divide, oh no, so what is 2Q? 2Q is, Q is 4M. I'm going to use M's now. So when P is divided by 2Q, 2Q is 8M, because Q is 4M. Now, when P is divided by 2Q, what do you have? P divided by 2Q is going to be, P is 43M, and 2Q is 8M. Oh, certainly the M's cancel. And now you got 43 over 8. And this is 5 times 3, 8. 5 and 3, 8. So, as I told you before, when you divide P by 2Q, and you divide it by 8, the remainder is 3. See? But this 3 over 8, they said, but here they tell you the remainder is 9. The remainder is 9. The remainder is, it need not be 3. It could be 3. You could have written 6 over 8 here. Or you could have written 9 over 6 over 16. Or you multiply them both by 3, you get 9 over 24, and so on. So the remainder is 9 here. So it means is 9, it's not 3. So therefore, what we are looking at is P over 2Q is equal to 5. And now we put in 9 over 24, you see. Because we have to make this into a 9. 3 over 8 is still the same as 9 over 24. And this way you got a remainder of 9. See? Because when you simplify this, 5 times 24 is 120. So it's 129 over 24. So now when P is divided by this, you'll see the remainder is 9. So P is now exactly equal to 129. See? So you know what the multiples are. And Q is 24. Only then you'll get the remainder of 9. And the question is, what is the remainder when P is divided by Q? Oh, this is 2Q, by the way. 2Q. So therefore, P is 129 and Q is 12. 2Q is 24. So Q is 12. So now we know P is, you know what P and Q are. So when you divide P by Q, what is the remainder? When you divide 129 by 12, 12 goes into this 10 times. That's 120. Right? And the remainder is 9. 12 goes into, the remainder is still 9. 120 divided by 12, 12 goes into this 10 times, and the remainder is 9. So this was the question. What is the remainder when P is divided by Q? The answer is 9. And see, this is quite a searching problem, although you're just working with ordinary fractions. And the idea is that it's a very beautiful problem because it tests exactly what you mean by writing a mixed fraction. And what do you mean by writing a single number as a fraction. There are many ways in which you can write a single fraction, so you must be very careful, right? So if you so when you say P over Q equals 43 over 4, you have to be very careful. Don't say P equals 43 or Q equals 4, right? There are infinitely many possibilities for P, right? You just have to multiply this by any number you would feel like. All right, so that takes care of that, and then we go into the next problem. Okay, the number 49 is special. Oh, why is it special? What makes it special? Because it is possible to add the product and the sum of the digits to get 49 again. Oh, all right. So we have the product of 49, the digits of 49 is 4 times 9. And then the sum of the digits is 4 plus 9. When you add 4 times 9 is 36 plus 13, you get 49. So you come back to your original number. So it's special. Right? So the question is, how many two-digit positive numbers are there? Positive numbers. Positive, you should say positive special numbers. Are there in total? 49 is one of them. All right, so how do we find all these special numbers? Okay, to answer the question, we need to look at what do you mean by writing a number with its two digits. If you write a number like 57, right? If I write this thing as AB, you get the feeling that this is A times B. But if I'm saying A is a digit, 5, and B is a digit, if A is 5 and B is digit, I can write it as AB, but this is not a product now. You have to be careful. Some people actually use a symbol like that, some symbol, to show that A is the first digit and B is the second digit. Right. But I abuse that notation when there's no confusion. I put AB, it means does not mean product. So you just understand that. Okay. But now what is the actual value of, okay, let's say that we're referring to this. Then what is the actual value? This 5 is tens, so the 57 is actually equal to 10 fives and 1b, that's unit, right? So this is 10 times 5 plus 7. So in general, a two-digit number AB, I want to write it like that, is 10A plus B. And a three-digit number will be 100A plus 10B plus C. Now just remember that. Yeah, the A stands for digits, and this is the three-digit number, and I'm putting it in brackets to distinguish it from a product. See? All right, so we don't know what the numbers are. Let AB, we'll put it like this, be such a number. The question is how many two-digit numbers are. And so we need to have that A is positive. Right? The first digit can't be 0. It's a two-digit number. So A is greater or equal to 1. Be such a number. So it says that that number, the original number, which is AB, is equal to the product of the numbers. Now it's A times B. This is product. Product plus the sum of the digits, the A and B. So this side, this is actually 10A plus B. If I take the brackets out, this is the two-digit number. Now I got an equation. See, as long as you got an equation in mathematics, you can make progress. And that's most of the problems, algebraic problems, involve equations and solving for those unknowns. Right? Now, if you do this, you see the b's cancel, and you have 9a equal to ab, 10a minus a. A is greater or equal to 1, so I can divide by a. You can't cancel. Be very careful when you're canceling. Sometimes people just cancel. When you cancel, you are assuming it's not equal to 0. So this means that either a equals 0, right? Or if a is not equal to 0, you can have 9 times 0 equals 0 times b. Both are 0. Either a equals 0, or then you can cancel. And you can say b equals 9. But we know a is greater or equal to 1, so therefore b equals 9. So b equals 9. But nothing is said about a. So the information that you got only tells you it's the value for b, which means that any a will do. See, you can put, if b equals 9, you put a equals 50, 50 times 9 is 9 times 50, right? So no matter what you put for a, this equation will work, see? So the two-digit numbers are, the b is the second digit, so the first digit is 19, 29, a is the first digit, any a will do, but it can only go up to 99. And note that 49 is one of them. It crossed 49. That is the example that was given. Right? So all the numbers, they say how many, and the answer is 9. Must answer the question. These give you all the two-digit numbers which have this property, and there are 9 of them. The question is how many such two-digit positive numbers are there, and the answer is 9. 1 to 9. Okay. All right, so we've just got 6 more minutes. As you can see, I'm going through this briskly, and it's going to be recorded, so you can always go back. Okay, now we go to the next question. Right. So here, let's read the question. In a class test, each learner scored 4, 5, or 8 points. Very few points. The number of learners who scored 4 points. Okay, we don't know how many learners scored 4 points. Is the same as the number who scored 5. So we don't know how many learners scored 1. So let's just draw a table here. It's always useful to draw a table. I like drawing tables in problems like this. I'm going to put A, B, C, D. A, B, C, D. A students scored 1 point. B students scored 4 points. C students scored 5 points. And D students scored 8 points. These refer to students or learners. When I was in school, the word learners didn't exist. We just say learners, school students or pupils. But then there came a time when people were saying we should use learners because sometimes the adults, who are learning. Okay, and this is the number of points that they each scored. The number of learners who scored 4 points is the same as those who scored 5 points. So we are given that B is equal to C here. I'm just going to put B equals C. Right. Then we say the number of points scored by the class. Right. How many points were scored by the class? Total number of points. Well, A of them scored 1 point. B of them scored 4 points each. So altogether, the B's contributed 4 B points. The C of the students scored 5 points. So those students contributed 5 C points. And likewise, those who scored 8 points contributed 8 D to the total score. So this is this. And they say that the number of points scored by the class is 63 more. So in other words, this is 63 plus something. Then the number of learners in the class. How many learners are there in the class? You've got A plus B plus C plus D. So there it is. You got the equation. Once you got the equation, you should have a smile on your face because it means now you can make some progress. Okay. So let's see. I'm going to write this thing out in full. I can actually remove the brackets here quickly, so I don't have to waste any time. And so if you remove these brackets, then you have, if you bring all the A's to one side, oh, A's actually cancel. You got 4B, you got B. So you got 3B, 5C, and C. 5C minus C is 4C. And 8D minus D is 7D. Bring all the A's, B's, C's to one side, but I'll leave the numbers on the other side. Okay, so you got one equation with 3 unknowns, but you can't solve that. But anyway, B is equal to C, so that's fine. These two are the same, so I can make this B equal to C, so I can make the 7C plus 7D equals 63. Oh, that's very nice, because then I can divide by 7, and I get C plus D equals 9. I still don't know what C and D are. I got rid of, I don't even know what B is, but what these numbers are. But all we have is that C plus D is equal to 9. What is the question? How many learners scored 5 or more points? C scored 5 points. D scored D learners scored 8 points. The ones who scored 5 or more points is all the C's and all the D's. So the question here is, what is C plus D? I should have written the question right in the beginning, right? So those who scored 5 or more points is C plus D. And that's exactly what we calculated here. Without knowing what A, B, and C, D are, we can answer the question. The answer is C plus D is equal to 9. See? Very nice question. You don't have to calculate any of these unknowns, yet you can answer a question. Because they say 5 or more, you see. They didn't say score exactly 5 or score exactly 8. Okay, so that takes care of that. And I think now we are at it's already 6:31. So I should be stopping here. Okay, let me just see how many questions I still have to do. So these, I will start them off maybe next week, or otherwise I will send a message through to your center manager and tell them this should work out. Oh, there are quite a few. There are 5 questions here which I haven't done, but some of them were quite difficult. It took a long time. All right, so you got 5 questions which you can look at. I think we can think of it as homework. You can try these five and see how far you can go. So the next time when we come, if you had any difficulties, we will go and I'll give you the solutions to those problems. But it'll be interesting to work out those five problems. Mm, oh, wait a minute. You don't have those five because some of them are new. Okay, what I'm going to do is I'm going to post those five problems and I'll send them to your center manager and I will tell them that this is your homework. So when you come into the class in 2 weeks' time, I think the next time you come here is on the 31st or the 1st of. Oh, no, actually, you come back the next term, somewhere in July. So I don't see you again for a long, long time. You can work out these five. And at the same time, since you are on a holiday, after that, go ahead and do all the other sessions. Session 3, session 4, all the way up to session 10 and try the problems. Right? You will get stuck many times. It doesn't really matter. Go and look at the hints. I've given you the hints at the back of the book. And if you get really stuck, you can go and ask your center manager or your tutor. But just bear in mind that I am going to discuss those problems when we get to them. But in the meantime, you can your tutors and the center managers have got the solutions to all the problems. So they wouldn't have any difficulty. They might tell you, okay, call me again so they can go and study the problem. Uh, and when they get back to you, they will say, okay, now I know how to solve it. Okay. So thank you very much for attending and enjoy problem solving. Problems, as you can see, it's a very exciting world where you don't use any of all the stuff that you learn at school. Most of the stuff you don't is all in primary school, but you only use your common sense, get some equations and solve. All right, okay, let's now close up, and I'm going to just open up the class to everybody. And if there are any questions that you want to ask, you can ask it. All right, those who want to stay behind, you can stay. You might want to listen to some questions and see what the answers are. Anybody has got any questions? I see there's nothing in the chat column. Maybe I was going too fast. And I know last week there was Samsung SMAO. He doesn't give his name. He had a couple of points to make. He answered some questions, made some comments in the chat group. But this time there's nobody. Any questions? Persona? Persona, do you have a question?
I'm here.
Yeah, your mic is open. Do you have a question?
No.
No, then close your mic. Those who have questions, you can use this little thing called react at the bottom, and you can put your hand up. Right at the bottom, you'll see a heart shaped. Mine is a heart shape, but sometimes you've got other shapes. Please refer to the first question. That's Nasra is saying. All right, Nasra, you want to put your mic on and tell me why I should refer to the first question? What is really the issue about the first question?
I didn't quite.
Just one moment. Just one moment. I'm having a little bit of difficulty in getting to the first question. One moment. I'll get to it just now. All right. So what is the first question? This question about the clock.
Yes.
Yeah. Tell me, you want me to go over it again? What is it that you don't understand?
Can you please try to repeat it?
Nasra,
Yes.
do you want me to go over it again?
Yes.
All right. Let me explain. This is a rather tricky question, and you've got two times here. The blue picture is, or the black, I don't know what it is. It shows the 90 degrees, and that is the time there is something past 12 because it's just before 1. All right. And the something is actually 15 plus x. It could be 20 past 12 or 25 past 12 or something. But this is the number of minutes gone through by the long black line, the minute line. But in the meantime, the hour hand has only moved, I said here, it moved x, right? But the angle between them is 90 degrees. So using that fact that this is x here, it's moved only x, and the hour hand, the minute hand has moved 15 plus. Yeah, it's why 15 plus x, because 90 degrees in minutes. You see, 360 degrees is 60 minutes, right? So 90 degrees will be a quarter of that, 15 minutes. So this minute hand, if that is x, then this will have to be 15 plus x. But at the same time, we know that this minute hand moves 12 times faster than that one. So if this moved only x, then this would have been 12x. And that is where that first equation comes in. That 15 plus x is 12x. See? Because the minute hand travels 12 times faster than and it travels 12 times faster because the minute hand moves only 5 minutes when the hour hand travels 60 minutes, right? So therefore the minute hand is 12 times fast. 12 times 5 is 60. So this is how we got our two equations. And the problem was actually to find what is the number of minutes apart these two times. So you got the one time is this, and the other time is this. So how many minutes apart are these? So how many minutes are here? See? So we said that it's actually 45 plus y, that's the total number of minutes, and this is 15 plus x. So it's that number of minutes minus that number of minutes will show you how many minutes there are. And that is how we get 30 plus y minus x. And the only problem was to find y minus x. And in those two equations which we get, this gives you y minus x. So therefore the answer will be 30 plus whatever you got there. I hope that helps, Nasra. I'm not going through the entire solution, but those are the key points of that. Do you understand it a little bit better now, Nasra?
Yes, I do.
Okay, thank you very much. Okay. Any other question? Kotso, you can just read it out and tell me what it is and who's asking it.
I have a question.
Yes.
So we will calculate. What are we calculating exactly? What are we finding?
In which problem?
This problem that has clock in it.
Oh, I see. How many minutes apart are these two times? All right. Let's put it this way. Suppose the one time is 11:20 and the other is 11:36. How many minutes apart are these two times? You tell me.
Still calculating.
20:36.
Oh,
It's 36 minus 20, isn't it? 16 minutes apart, right? If you came into the class at 11:36 and the class started at 11:20, you are 16 minutes late. So this is the 16 minutes apart. So you have to subtract. The 16 is subtracting the minutes here from this minutes here. So that's what I got. The minutes here, I have to subtract it from the minutes there. And that is how you got 45 plus y minus 15 plus x. So that is the question. The question is how many minutes apart are these two times? And that's how I got that. So that is the question in this problem. So you have to calculate 45 plus y. You have to calculate this thing here. So that is what I was trying to calculate. And eventually I got 30 and 8/11 or something. Okay. Do you understand that now?
yeah, I understand. Thanks.
Okay, Sasona, thank you. Anybody else? Any other questions? Okay, so it seems that there are no further questions. Khotso? We can, yeah, I think we can sign off now. You can stop the recording, and the rest are free to leave. So goodbye, everybody. Until we've got a long